I'm Eitel Lauria, and as Carl was just saying, I work in plastics. So I thought that perhaps to try to hinge this talk with the previous talk, it would be useful to let me just go ahead. To discuss a little bit of topics in which I work, and some of the software platforms that are related, because in a certain way this whole project of this new hardware that we are receiving that has a big analytics component has a direct impact on me in a certain way. So topics in which I have been involved in the past and working on are more or less listed here. I work on academic analytics. I'm going to go in that in particular in a minute. I use a number of different tools in there. IBM SPSS model, as it was being mentioned, SPSS statistic for certain things. Weak and Kettle, which are two open source tools that are being developed for the open source market. I'm using SQL Server as the repository of the tools. In terms of metrics, in terms of data quality metrics, that's a topic in which I have been working for some time. I do work in data mining and data quality, and well, I've been using MATLAB, Python, numerical library of Python, and C also. I do some work in, I would say, data mining for healthcare coding, which is mostly a statistical machine learning approach, and again, a number of tools that I'm listing there. I've been working on Bayesian networks. I do some work on Bayesian modeling, and the last one is the one I was discussing about using OLAP for planning and forecasting. In particular, I'll be using TM1. We don't have time to cover all this, but I thought I would actually mention some of these topics in which I think some of these technologies may have a little bit more impact. So let me go into the Open Academic Analytics Initiative. This is actually a project that is currently funded during 2 years, and the whole idea is the following. As it was being explained, and the whole idea of business analytics, among other things, was to be able to do predictive modeling into the future. Well, the concept of business analytics, in a way, has been translated into academia to see if what we can do is the same idea of risk analysis that you do in business, you apply on the students, pretty much. Can we detect if certain students that may be at risk can be actually, well, in a way, detected in advance and informed about their situation in a way that would actually raise our chances of retention, among other things, and put students in a better situation. So questions that we have been asking for some time are pretty much how is it that we model, let's say, a way of detecting students that are at risk, which is a kind of data what we may be using at a certain point. I would say there's a lot of research in education done over the past about data that can be used in this regard, and well, demographics data is something that has been used. Although it sounds like a tautology, academic performance is usually the best predictor of academic performance. But although that's the case, the question is not trivial, because in general what we do is, in a post-mortem manner, what we are doing is using academic performance to, in a way, predict how good students are going to be. The question is, can we do something a little bit in advance or with partial grades, for example? And partial grades have never been really available because they are within the domain of faculty members. Well, today with some technology that is available out there, because there are some software platforms that may actually collect partial grades, we may eventually be able to do that. So use those partial grades to perhaps, in a way, try to determine that a student is not doing very well until, like they say in my country, the blood gets to the river in a certain way. So I come from Argentina, by the way. A number of, those are general research questions that I'm describing there. Can we add effort as a predictor, for example, and how do we measure effort? Can we use partial grades? Where do we collect measures of effort and partial grades? The answer there has been course management systems. We do have an educational platform that we can use today, and using that educational platform, perhaps we find a way of actually gathering, collecting data. So, with this said, we received this grant some time ago that focuses on open academic analytics. By open academic analytics, I'm referring to a number of open source tools. The reality is that this is going beyond open source tools because we have a very strong partnership with IBM on one hand. And so there are a number of tools that we have been using for some time. I'm going to go into more detail in a little while. This has been funded through EDUCAUSE, and EDUCAUSE is actually being funded from the Engage Foundation. That has been really a plus. Just to go into the architecture, because I think that this is completely aligned with what our previous presenter was basically describing. This is our current architecture at a conceptual level. Really, I'm not talking too much about the specifics of the tool, but this is pretty much what we are doing. We are sourcing data from different systems at Marist. That data that we are sourcing is pretty much demographics data, personal or biographical data, course data, performance data. By performance, I mean general GPAs, for example. But what we are also doing is sourcing data from our educational platform, which at Marist is called Sakai, an open source system, very broadly used across the world in a number of very highly reputed institutions. And from there, what we're doing is pretty much collecting some events that Sakai actually provide, being those events, let me put some extremes. How many times a student log into Sakai, number of sessions. How many times a student submitted an assignment. How many times a student participated in a forum, for example. In the extremes, you could say someone never logged in, never participated, never contributed, well, chances are that he or she's not going to do great. The other extreme, you could imagine that that is, in a way, an indicator that they're going to do better. Not necessarily. On this side, probably. On this side, it's not completely clear. But in a way, we're more interested on this side, that is, students at risk. What happens here, once we move beyond a certain threshold, we're pretty much okay. So, this goes beyond Marist because our grant actually includes a number of other institutions, and the institutions that it includes are a number of the American public university systems, Cerritos College, Howard University. And what we're going to be doing is once our model is actually laid out, we'll start, in a way, flowing data from this institution, streaming data into our own model at this point. We have an ETL layer that at this point is based on a certain software platform. We have a repository, which again is SQL Server. This is happening in a certain development testing platform that is running out of servicing in my office field. It's running Windows Server 2008. We have within this ETL platform, let's say, a number of software products, mostly coming from the open source world that actually allow us to extract, transform, and load this data. And then we get into the predictive modeling layer that actually does on the data a number of things, in a way pretty aligned with what our previous presenter was saying. We anonymize the data, partition the data, create a training data set, balance the data so as to bias it in the direction of what we want to detect, which is pretty much students at risk. We then use a number of algorithms. Actually, our best results are coming from using logistic regression and support vector machines at this point, although we're also doing some Bayesian modeling in that regard. And the idea is to create, let's call them a library of predictive models that would then actually allow us to do predictions, score, and produce results. That's, let's say, the flow of execution. At this point, we have this flow of execution completely implemented in SPSS. I am pretty acquainted with SPSS modelers. So it's the first tool that we actually approached. And we are going to then migrate this little by little into Pentaho Weka, which is the tool that is a data mining tool within the Pentaho platform. Weka is an interesting, Weka is a bird in New Zealand. It was a library developed by two faculty members at the University of Waikato in New Zealand. They have good rugby and strange birds. So this is pretty much one of the projects I was referring to. Second project, which I thought would be useful also to describe, because in a certain way, the previous project, it's interesting in terms of the different tools or IBM tools I was describing. This has more to do with computing muscle, really, and the tools that we were using were, or I was using, was really a little bit low end, C or C++, Python as a glue, and really a numerical library based on Python that it's really C or C++ based in reality. So in this case, the problem is the following. With a colleague of mine, we have been working for some time on trying to develop an improved accuracy metric. When it comes to databases, a big issue that is measuring in many cases how many errors, or what's the error rate, or what's the accuracy of a given database. And the problem is that usually the only measure is taken into consideration is just an error rate. And that's not good enough, because among other things, the error rate is just telling me how many errors I have per number of records, for example, but it says nothing about the distribution, the systematicity of the error, the randomness of the error. So it's something that we worked for some time, was trying to see if we could actually find a good measure of randomness. And well, one of the many measures that we considered was actually a variation of what is known as Kolmogorov-Chaitin complexity, basically. And to put it simple, and it's perhaps those are 2 or 3 big words, but it's simple to understand. Let's say that I say something like the following. Argentina will be the next world soccer champion. That's 48 characters, including the blanks, okay? The smallest program I can write to repeat that statement 1,500 times is, or I is equal to 1,500 times that statement. If I scramble the words, the letters, I mean, 1,500 times, now what I have is something which is completely random. What is the smallest program I can use to represent that? Just the enumeration of the data. So in a way, Kolmogorov complexity is basically measuring that randomness as tied to this idea of compression in a certain way. So we thought that this could actually be a very interesting approach, because something like this is not compressible, something like this is very compressible. So this is not the only application in which it has been used. Biomedical signals are processed in this way. Very recent research, for example, measures electrical signals in the heart. And if you have, let's say, non-compressed signals, you should go to the ER because you have a problem there. I mean, there is some randomness in your electrical signals in the heart. So our problem in this case was finding a way to compute this metric. And, well, I'm not going to go into all the detail, but Kolmogorov complexity is really a theoretical metric. But what you can do is apply like a variation of that theoretical metric, which is a practical metric, which is Lempel-Siv complexity. We all know about Lempel-Siv because we use it daily. That's variation of Lempel-Siv is our zip files, pretty much. What we do in zip files is exactly that. And the whole idea is that the LC complexity is basically can be measured as a number of distinct or disjoint strings out of a sequence that you produce, starting with small substrings and going to greater and greater sequences. Okay, so for example, I have an example here. I have a sequence which is 0, 1, 0, 1, 1, 0, 0, 1, 1. And the vocabulary, that is the sequence that you're going to produce, is 0, 1, 0, 1, 1, 0, 0, 1, 1. That is the complexity for this sequence is 5. Actually, there is some research done in terms of computing the asymptotic value of a sequence of this kind, that is of the Lempel-Siv complexity. And if you compute the ratio of that number, that gives you a number which is independent of the size of the sequence, which is extremely valuable. Now, the problem, as always, is how do you compute the sequence? The time complexity of computation of that sequence is about n squared, which is tractable, but if you have a file with millions of bytes, well, I made some runs, I pressed the button and went away, and 2 days later I came back, I mean, considering the muscle that I had in my server, I would say. So this is pretty much what would be helping us in this case. More computing muscle is greatly appreciated in this case. Programming platform in this case is starting, let's say, using MATLAB. MATLAB is a critical environment where you can do prototyping, but sometimes you need to go beyond that. I compiled MATLAB, then I transformed this into Python, into C or C++ to make it faster, tried vectorizing it using some of the NumPy libraries, but still, I mean, there are a number of issues there, especially if what you try to do is compute large windows. A way of approaching the problem is you will never take a big data race and try to compute of that randomness. What you do is you take windows, and of those windows, you come up with a computation, and then you kind of average it to understand what's the average randomness of the data race that you're considering. But even so, if what you want to do is extend the size of the window, that actually becomes a problem. So again, it's an interesting problem in terms of understanding where computing muscle actually plays an interesting part. Things like you were mentioning today about enhancing computing muscle in an appliance of this kind is certainly welcome. I think I could go beyond that, but I would rather go back to what I was describing here, just to give you a sense of topics in which I'm working also. I do have a few slides on topics regarding automatic healthcare coding. The problem there is there in a way in which we can, for example, do automated assignment of the typical medical codes that are being assigned at the medical office, for example. We're talking about a corpus of thousands of codes, healthcare codes in many cases. And pretty much it's a text mining problem. What you're trying to do is, out of the diagnosis provided by the doctor, you're trying to automatically assign a code. It's a very difficult problem, but it's a problem which is addressable in a certain way. And you need a combination of both things. Good computing muscle on one hand, and on the other hand, good optimizing, I would say, query processing to do all the pre-processing at the beginning. And finally, well, the basic modeling thing in social science is probably not so critical, because in general in social science we don't have too much data. I mean, data's always in the hundreds, it's never in the millions, so that doesn't seem to be a big issue. This is not also an issue in terms, I'm referring to the last one, the OLA for planning and forecasting. It's not so much about an issue in terms of scalability, but yes, in terms of integration of the products. One issue that I have, and this goes beyond research, goes much more beyond my own teaching, for example. My class, I'm combining a number of tools, for example, Cognos sitting in our current mainframe infrastructure, trying to talk perhaps against a TM1 database that is running out of a Windows platform, for example. That integration today is at least convoluted, I would say. Evolving into a platform that is much more uniform, it's something that we would really welcome in some way. So I think that that's pretty much questions about any of this.
Carl, one thing that Eitel didn't mention is, this is research, but on the academic side, we have, he sort of mentioned it just now, to support some of his courses, his business intelligence, business analytics courses. We do have Cognos, SPSS, Modeler, TM1. We have Infosphere Warehouse. We're not really using it yet, but
yeah.
And so we kind of have this environment starting to build it here in America.
Yeah, one thing that I'll throw it out, I don't know if it's of interest, but for instance, for SPSS, there are a couple of reference blueprints. So there's one on fraud detection and risk analysis for like a bank, and you can download essentially a VMware image, and it comes with the menus, the data, and everything, and bring it up and run it. So that's obviously going to be on an x86, I don't know if it's Windows or Linux environment. And then it would be interesting to start to pull pieces of that over to the Z environment, but also students theoretically could just download that and play with it if they have access to that software.
And when is T1 going to be available on T1 again?
I have to check that. It's I think within the next 6 months, but I can validate that.
One point that we have been trying to work, but that had more to do with, again, with our teaching, nothing more than anything else, was trying to, we have a big, let's say, infrastructure with Cognos running here, and Cognos is pretty much looking at one data repository at this point, which is the V2. Something that we want to explore is making that a little bit more portable, in the sense that we may be looking at Oracle or SQL Server or other repositories across the world, because that makes it more flexible.
Right. I'm not well versed in the area, but Cognos has connectors, I think, to all the major backend databases, and there's also Classic Federation on the Z side that can be used. I don't know, there may be some gaps there, but if you've got questions about Cognos on Z and the roadmap, the missing components or whatever, I work very closely with the person responsible for Cognos on Z, and I can forward those questions on. Right. And same with SPSS. We're also looking at which math libraries we should pull over. So that's, I actually regret that I did not invite one of my colleagues to come along with me, but he's been doing some investigations into BLAS and things like the PAC and so forth as to which one should we focus on and bring over and get running. ZOS and ZLinux. So,
Maybe have some follow-on discussions.
Definitely. All right.
Okay, I think we'll end it there. So thanks very much to Carl Paris and Dr. Eitel Lauria.